Hello, my name is Al Palmer. I've been teaching here at Montcalm Community College for about the past 10 years. We started using these trainers, and as we were running through this material over the last several years, I found there was lots of areas where the content wasn't complete from Amatrol. And since they're the content providers for this material, I thought I'd make some videos that would supplement the material that they're presenting. So the very first learning activity packet that you have to do is, the second thing down from the top, is connect and operate a power supply. So I wanted to talk about this power supply because you're going to be using it for the whole semester and you should know what's going on inside here. So it's pretty straightforward as far as on and off, but from there on, this is like no power supply you'd ever see in industry or at any manufacturers or supply houses. And the reason is, this is an AC power supply and a DC power supply at the same time, which is kind of a rare bird. So what I want to explain to you is what goes on inside here and what's kind of behind the scenes a little bit. So when this is on AC, basically all that's in here is a transformer. And I want to talk about that transformer a little bit. That's a transformer. Electrically, the schematic looks like this. And it has a winding that's plugged right into the plug, 120 volts AC. And it has a 10-to-1 turns ratio, like this. And so it has a winding that looks like this. And since the turns ratio is 10-to-1, the voltage ratio is 10-to-1. So the voltage coming out here is about 12 volts. Now I say, and it's AC, and I say 12 about because they overwind these windings just a little bit because this winding is capable of putting out 5 amps of current. They overshoot the voltage a little bit and unloaded, which means without anything hooked to it, it's actually about 14. And then if you were to hook a load that would draw 5 amps, it would make its rated output power, output voltage, which is 12. And so the 10-to-1 works, but they've given you a little bit of fudge factor just to make sure that under load it doesn't drop down below its rated voltage. Now the other thing that's different, which is still typically normal, is there's 2 of these windings that are both 10-to-1 turns ratio, and they both put out 12 volts AC. They're both rated at 5 amps. And then the top of one is connected to the bottom of the other. And so what that does is it puts these 2 windings in series. So if you were to measure across them from here to here, you would actually get 24 volts AC. So when you put this power supply on AC and turn it on, you get the 12 volts AC here, which is actually 14 unloaded. 12 volts AC here, 14 volts unloaded. But what happens is if we measure from here to here, it's actually closer to 28 volts or 24 volts if it was loaded. And this black connector right here is the center tap, which would be connected right here. And so this is a transformer. That's all that's connected to this when you put this on AC. And a transformer, if you were to look at a power supply, this is similar, is this part of the power supply right here. This is a fairly large one, but transformers come in all different sizes. I mean, they can be as big as a minivan or small enough to hold in your hand. This is a transformer that's rated at about 20 amps at 12 volts. And this is a corresponding power supply, the rest of the circuitry here, to turn that AC into DC. Because this is actually a DC power supply. And this becomes a DC power supply when you flip this switch to here. And so what you've done is you've just invoked an entirely different power supply mounted inside this cabinet that basically is 2 power supplies in one, and they're hooked up almost the same way. So what happens is you have a power supply, and the schematic symbol is that. It's just a battery. And it's a 12-volt battery. Once again, I think it's rated at 3 or 5 amps, I'm not sure. And there's 2 of these in here like this. And so they're connected top to bottom. So if you go from one end to the other, this one, in respect to the center, is plus 12. And this one down here is minus 12 because it's hooked to the bottom of the 12-volt power supply. So they are connected in series like this. And so if you went from here all the way down to here, you get 24 volts DC. And these are really accurate. When they say 12 or 24, they're exactly that, or very, very close. So I'm going to hook this up, and I'm going to show you how this works. Now, I'm going to put this meter on 12 volts, on 20 volts DC. Plug the leads in. And I have this on DC. And I'm going to hook up this meter, and this tells you right here is 12 volts. Can you see the meter? Okay. Then when I hook it to here, leaving the common in the same place, I have minus 12. If I hook the meter up across both of them, first thing it's going to do is say overload, because it's more than 20, so go to the 200 volt range, and it'll say 24 volts. If I flip this to the other side, it says minus 24, because this is a polarity sensitive meter and a polarity sensitive power supply. When I flip this to AC, be careful, watch what happens. I've got the meter on DC, and the power supply is now putting out alternating current, and I hook this up, and the meter says 0. Why? Because I'm asking it to tell me how many DC volts are here, and there are 0 DC volts, even though there's 14 AC volts. If I flip the meter over to the AC range, all of a sudden you'll see, okay, there's the 14 volts. There's no polarity with AC because it's constantly varying polarity. So if I switch sides, I get 14 volts again, 13.9, 14, whatever it settles in at. And if I go from one side to the other, I will in fact get the 28. Whoops, I'm on the 20 volt range. I got to go up to 200, and this will settle down pretty close to 28, 29 volts right there. So I'm going from the top of the power supply transformer all the way to the bottom for 28 volts. So this is rated in 24 for 24 volts. These light bulbs can handle 24 volts. If I hook them up, the light bulb is going to light up, and there's the 24 volt light bulb. If I hook this on DC, it's only half as bright because I've only got the 14 volts now. Now here's the thing, RMS, root mean square, it's a little farther advanced math, but when the RMS value of an AC voltage is equal to its DC equivalent. So if I flip this from AC to DC, the bulb will only change brightness a small amount, because the bulb doesn't care whether it's being lit by 12 volts AC or 12 volts DC, and the bulb doesn't care about polarity. So it's going to be pretty much the same brightness. You'll see a small change in brightness when I go to AC because the AC voltage is just a little bit higher than the DC voltage. Now, I've got this on AC. When I plug it back into the meter again, like this, here's my AC volts, just like I showed you a minute ago. There's 12 or 24 if I hook it across. If I flip this to DC, once again, it will tell me 0 because this meter discriminates between AC and DC. If you're going to measure a voltage, you have to know what you're looking for. You can't randomly jump in and go, it doesn't matter. If I wanted to measure the voltage coming out of an outlet and I put this meter on DC, it would tell me 0, even though there's a lethal voltage there. So you have to make sure that you have the meter on the DC range or the AC range, depending on what you're expecting to see. Everything in your automotive applications are going to be direct current, and everything in your home wiring is going to be alternating current. Why am I making a deal out of this with the meter? Because Amatrol comes with a meter right here. And it's an old style meter that is used to make things simpler for you, but I think it's more confusing. The front of the meter says AC volts. So, whoops, wrong lead. If I plug this in, I blew the breaker. If I plug this in, the meter will in fact tell me that I have 14 volts here. And it says that. And if I put it here, it says I have 28 volts. And that's fine. The meter says AC volts. The problem here, I think the confusing part, is if I flip this to DC, this meter doesn't know the difference between AC and DC. This meter is odd. You will not find meters in industry that can measure AC or DC voltages. This is the weird thing, and I think it can be dangerous in certain applications where it may be implying to you that it doesn't matter if a digital meter is on the correct AC or DC range. So this one doesn't know the difference between AC and DC. This one, you have to have it on the right range. I hope this helps, and I'm going to make a whole bunch of these movies as we work through the semester, and maybe it'll make doing your learning activity packets a little bit easier. Thank you.